electrical duct heating does not satisfy the requirement of electric space heating for the purpose of optional calculation for multifamily dwellings as per National Electrical Code Article 220.32. This specific requirement in Article 220.32 states that each dwelling unit shall be provided with electric cooking equipment and shall also be provided with electric space heating equipment for the purpose of calculating the feeder and service loads where the dwelling units are supplied by a single feeder. Electric space heating equipment refers to systems designed to provide warmth to living spaces, such as baseboard heaters, wall heaters, or radiant heating systems. Duct heating is a type of heating, ventilation, and air conditioning, or HVAC, system that uses heated air to warm a space, but it is not considered electric space heating equipment under National Electrical Code definitions. Therefore, since the dwelling units in question are supplied with electrical duct heating instead of electric space heating, the optional calculation method under Article 220.32 is not applicable. The feeder and service loads must be calculated using the standard methods in accordance with Article 220. To understand this further, let's break down the relevant concepts and code requirements. Firstly, National Electrical Code Article 220 covers the calculation of branch circuit, feeder, and service loads for electrical installations. These calculations are essential for determining the appropriate size of conductors, overcurrent protection devices, and equipment to ensure the safe and efficient operation of electrical systems. Secondly, the optional calculation method provided in Article 220.32 is a simplified approach for calculating feeder and service loads for multifamily dwellings under specific conditions. This method is designed to reduce the calculated load compared to the standard calculation methods, but it is only applicable when certain criteria are met. Thirdly, the specific conditions for using the optional calculation method in Article 220.32 include that the multifamily dwelling is supplied by no more than one feeder and that each dwelling unit is equipped with electric cooking equipment and electric space heating equipment. This requirement ensures that the diversity of loads within the dwelling units can be adequately accounted for in the calculation. Fourthly, the term electric space heating equipment is used in Article 220.32 refers to heating systems that are specifically designed to provide warmth to living spaces through the direct conversion of electrical energy into heat. Examples of electric space heating equipment include baseboard heaters, wall heaters, radiant heating panels, and electric furnaces. Fifthly, electrical duct heating, on the other hand, is a type of heating, ventilation, and air conditioning system that uses heated air to warm a space. In an electrical duct heating system, electrical resistance heating elements are installed within the ductwork of the air distribution system. Air is forced over these heating elements, and the heated air is then circulated throughout the building via the ductwork. Sixthly, while electrical duct heating does provide heating to the space, it is not considered electric space heating equipment under National Electrical Code definitions. This is because electrical duct heating is part of a larger HVAC system that includes air distribution components, while electric space heating equipment is typically a self-contained unit that directly heats the space. Seventhly, because the dwelling units in question are supplied with electrical duct heating instead of electric space heating, the optional calculation method under Article 220.32 is not applicable. This means that the feeder and service loads for the multifamily dwelling must be calculated using the standard methods in accordance with Article 220. Eighthly, the standard calculation methods in Article 220 involve calculating the load for each individual branch circuit, feeder, and service based on the connected loads and applicable demand factors. These calculations can be more complex and time-consuming than the optional calculation method, but they provide a more accurate assessment of the actual load requirements of the electrical system. Ninthly, when calculating the feeder and service loads for the multifamily dwelling, it is important to consider all applicable loads, including lighting, receptacles, appliances, heating, ventilation, and air conditioning. Demand factors can be applied to these loads to account for the fact that not all loads will be operating at their maximum capacity simultaneously. Tenthly, in addition to the general requirements of Article 220, there may be specific requirements for calculating the load for certain types of equipment or occupancies. For example, Article 220.14 provides specific requirements for calculating the load for show windows, and Article 220.18 provides specific requirements for calculating the load for dwelling units. 11thly, to ensure compliance with the National Electrical Code, it is essential to carefully review all applicable code requirements and consult with a qualified electrical professional if needed. Proper load calculations are critical for ensuring the safety and reliability of electrical systems. 12thly, in summary, electrical duct heating does not satisfy the requirement of electric space heating for the purpose of optional calculation for multifamily dwellings as per National Electrical Code Article 220.32. The feeder and service loads must be calculated using the standard methods in accordance with Article 220. Let's explore some of the specific sections within Article 220 that are relevant to calculating these loads. Article 220.10 covers general requirements for calculation methods, stating that feeder and service conductor load calculations shall be determined by either the general method in Part 2 or by one of the optional methods in Part 3. Article 220.12 details the general lighting loads, specifying the minimum lighting load in volt-amps per square foot for different occupancies. For dwelling units, this is typically 3 volt-amps per square foot. Article 220.13 allows for reductions in lighting loads based on certain conditions, such as the use of energy-efficient lighting fixtures. Article 220.14 covers receptacle loads, specifying the minimum load for general use receptacles in various occupancies. For dwelling units, each receptacle outlet is typically calculated at 180 volt-amps. Article 220.16 addresses appliance loads, requiring that the load for appliances be calculated based on their nameplate ratings. Article 220.18 provides specific requirements for calculating the load for dwelling units, including the application of demand factors to range, dryer, and air conditioning loads. Article 220.30 is the start of Part 3, Optional Calculations, and it states that the optional calculation methods are permitted only where all of the following conditions are met. Firstly, the calculations are performed for a new or existing dwelling unit or multifamily dwelling. Secondly, the dwelling unit or multifamily dwelling is served by a single feeder or service. And thirdly, the total load is not likely to exceed the ampacity of the existing feeder or service conductors. Article 220.32, as we've discussed, provides the optional calculation method for multifamily dwellings. It requires electric cooking equipment and electric space heating equipment in each dwelling unit. Since electrical duct heating doesn't meet the definition of electric space heating equipment, this optional method cannot be used. Article 220.82 is the optional calculation for dwelling units. It allows for a simplified calculation of the service or feeder load for a dwelling unit based on the total connected load and the application of specific demand factors. Now let's talk about demand factors. Demand factors are multipliers that are applied to connected loads to account for the fact that not all loads will be operating at their maximum capacity simultaneously. These factors are based on statistical data and engineering judgment and are intended to provide a more realistic estimate of the actual load requirements of an electrical system. Demand factors vary depending on the type of load, the number of loads, and the occupancy of the building. For example, demand factors for lighting loads are typically lower than demand factors for motor loads, as lighting loads are less likely to be operating at their maximum capacity for extended periods. In the context of multifamily dwellings, demand factors are often applied to the loads of individual dwelling units to account for the diversity of loads within the building. This means that the total load for the multifamily dwelling will be less than the sum of the individual dwelling unit loads. However, it is important to note that demand factors should be applied judiciously and should be based on sound engineering judgment and a thorough understanding of the load characteristics of the electrical system. Overly optimistic demand factors can lead to undersized conductors and equipment, which can compromise the safety and reliability of the electrical system. Now, let's consider the implications of using standard calculation methods versus optional calculation methods. Standard calculation methods, as detailed in Part 2 of Article 220, involve calculating the load for each individual branch circuit, feeder, and service based on the connected loads and applicable demand factors. These calculations can be more complex and time-consuming than the optional calculation methods, but they provide a more accurate assessment of the actual load requirements of the electrical system. Optional calculation methods, as detailed in Part 3 of Article 228, provide simplified approaches for calculating feeder and service loads under specific conditions. These methods are designed to reduce the calculated load compared to the standard calculation methods, but they are only applicable when certain criteria are met. In the case of multifamily dwellings with electrical duct heating, the optional calculation method in Article 220.32 cannot be used because the dwelling units are not equipped with electric space heating equipment. Therefore, the standard calculation methods must be used to determine the feeder and service loads. This will likely result in a higher calculated load compared to what would have been obtained using the optional calculation method. However, it is important to ensure that the electrical system is adequately sized to handle the actual load requirements, even if this means using larger conductors and equipment. Remember that the primary goal of the National Electrical Code is to ensure the safety of people and property from hazards arising from the use of electricity. Compliance with the code is essential for protecting against electrical shock, fire, and other electrical hazards. Therefore, it is important to carefully review all applicable code requirements and consult with a qualified electrical professional if needed to ensure that electrical systems are properly designed, installed, and maintained. In the specific case of multifamily dwellings with electrical duct heating, it is important to pay close attention to the requirements for calculating feeder and service loads. The standard calculation methods in Article 220 should be used, and all applicable loads, including lighting, receptacles, appliances, heating, ventilation, and air conditioning, should be considered. Demand factors can be applied to these loads to account for the fact that not all loads will be operating at their maximum capacity simultaneously. However, demand factors should be applied judiciously and should be based on sound engineering judgment and a thorough understanding of the load characteristics of the electrical system. The National Electrical Code is updated regularly to reflect changes in technology, industry practices, and safety standards. It is important to stay up to date on the latest code requirements and to consult with a qualified electrical professional if you have any questions or concerns. By following the National Electrical Code and working with qualified professionals, you can help ensure the safety and reliability of electrical systems in multifamily dwellings and other buildings.